Let's look at the effect of the private modifier and what it has on both instance and class. Let's draw these two classes. One of them is class C, another one is class test. Inside class C, we have a Boolean private indicated by this red X variable. Test, on the other hand, has a reference to C here. So is class C with a reference to C. This is small as C here, noting X as private. Now, inside this class C, we can do C.X, even though X is a private data. The reason is because private data could be accessed within the class itself. This is the reason why we don't get into compilation errors when you refer to its private member. Notice that this main, even though this main is an entry point or static, it is part of this class, C. So when inside the main, you call C.X, this is valid. Let's look at this C.X in test. C is an instance. When you C.X into this data member, which is private, you're getting a compilation error. The reason is because test is not the same as C, so test does not have access to C's private member. This is not possible. What is the lesson learned here? The lesson is a private data member is accessible within a class, but not by an instance, because this instance is clearly outside of the class. So you cannot do instance object.x outside of this class. This is a very interesting fact, and that is private data member can only be accessed when the class is being declared and defined, but not when the instance is created. This is the ultimate security protection by using a private modifier. The fact that private fields and methods are accessible only within the same class is of paramount importance in data encapsulation. This is the premise in OOP, object-oriented programming, to protect information. Not only protecting static data, but protecting info retrieval. Why does it make code easy to maintain? If you have your data as private, you don't have to worry about it being exposed to the outside world, outside of the class, that is. You can set up what's called the getter and setter on the private data to allow external entity, including its instance, to access that private data. And it is up to the developers to whether the data should be accessible through these getters and setters, or mutators and accessors methods. Instead of doing O.x, assuming O is the instance of some class and X is its data member that is private, you will invoke its accessor methods like O.get X to read your private data that way, or to set O.set, or to set its data with a set X by whatever data you have. This allows you to update or modify the data value in your private data. This makes your code a lot easier to read and also easy to maintain, knowing that all of your private data are protected through this data encapsulation or private modifier. Let's look at some examples. This is an example of data field encapsulation. Again, we have the UML representation of this class circle. Noting the minus sign, this indicates this particular data field is a private. Because this is a private, there is no way for other instances of the circle to access it. Therefore, we see accessors methods like get radius and set radius. These are public. So as a developer, you get to decide whether you want to expose this radius private data through accessors or not. We also have the get number of objects as a static method. This means that you can do circle, the class name, dot get number of object to fetch the number of objects, which is also a static member, regardless of which instance of the circle object you're in. This class circle with use of private modifiers and also static plus accessor methods on top of the private data gives rise to data field encapsulation, which hides the internal state of an object and requires that all interactions with the object occurs through well-defined interfaces or methods. Data field encapsulation also ensures that the internal state of an object remains consistent and that the object's integrity is maintained. Note, encapsulation is one of the 4 fundamental principles of object-oriented programming, short for OOP, alongside inheritance, polymorphisms, and abstraction. In summary, by encapsulating data fields and providing controlled access through these mutators and accessors methods, you can create more secured and manageable Java applications.